Welcome back to Track Talk. In this video, we're going to be doing a little bit of an update on our data analysis project, and specifically our recent efforts to cluster 18xx games based on their map development to see what kind of strategic insights and patterns we can detect in this set of data. Where we left off last time was with basically what I'm showing on the screen here, which is an attempt to identify features of specific clusters of games for a variety of game titles. So we've been looking at 1889, 1846, and 1830 since they have the most data. This is an example of data from 1889, and we are basically just trying to determine if certain game maps within the data set had anything in common with one another, and if so, if there was any specific strategy that was in common amongst those maps. So this map shows that, for this specific game, which tiles with which rotations were laid, and this is basically just a snapshot of the end of the game. So we've looked at these type of games in aggregate and tried to compare these endgame states to see if there was anything in common. And really, where we left things with the last video was that we didn't have a whole lot to show from that. And I think that even in that video, I had kind of suggested that there's at least two pretty major flaws with this approach, and where we'll be going with the analysis in this video is our attempt to address those flaws and see what new conclusions we've been able to glean. So to the two flaws that we identified in the last video are that just analyzing the games based on the tile and its rotation is really kind of inadequate. It's kind of a naive way of looking at the game state and the network that has been created. Looking at a tile and its rotation in isolation tells you really nothing about its connections with its neighboring tiles, and it also doesn't really capture the intricacy of the network within a tile. So you can tell that just because we have, this tile here, we really don't have very much information about the connections from the edges, the connection from edge 1 to edge 4 here, or the connection from edge 1 to 0. It's really all just implied by capturing the tile. We're not explicitly dealing with that internal network. And I think that's really a big shortcoming of this approach, and a reason why we're really never going to get meaningful data from such a simplistic view of the map. The second flaw in this type of analysis is that we really were just looking at the end game map, and that is just woefully inadequate for any type of strategic analysis. And I have a couple of examples that I'd like to just briefly run through to illustrate why this is such a big problem for this type of analysis. And I think the easiest way to do that is just with a example from 1889. I haven't de-identified these games. There's really nothing in particular special about these games. I'm just using them as an example. But I want to just flip between the end game states of these two games and then walk through the evolution of those game states to see how even very dramatically different games can end up looking, roughly similar at the end. So this is 1889, game 1, and you can see that we have this kind of peripheral pattern of development around the edge of the map, and then we have a little bit of an internal development connecting the east and the west in the center of the map here. So that's game 1, and then in game 2, we have, again, a peripheral pattern around the edge of the map, and then this kind of central area here where the east and west are connected. Now, there are some differences between the map. I'm not going to pretend that they're exactly the same, but I think that if we just flip through them back and forth, you can see that in the grand scheme of things, they're pretty similar. So now, if we look at the game quickly as the map develops, we can start to see how they differ in their evolution. So this game, we have a pretty standard development with the TR heading down south. We have relatively common companies starting, and they're taking relatively standard openings with the IR heading to Saiju and Marugami developing towards the east as well. And as we kind of click through this, we're just going to go through this very quickly as a time lapse. I don't mean to really delve into this in detail. We're seeing that everything's kind of developing very standard here. We have this peripheral development and early internal connection, but everyone's kind of just playing as you would expect if you were to play this according to the meta. So we're reaching the end of the game here, and this is kind of the mostly finalized game state. And I just want to contrast that with this other game that we said, generally speaking, looked pretty similar, and show you just how crazy this game gets in comparison. So already we have a single company floating. It's operating around 2 before anybody has able to float. That's pretty weird. And then if we look at the track that's developing, this is unusual IR track. The TR is going to follow suit and develop a little bit oddly as well. But already we're in operating around 4. This is a much slower development, and the track is just totally unusual. So if we just look at the end game state of this game, we're really missing how crazy this game was. And you can just see this is all just really unusual track here. The TR, instead of heading towards the west or trying to get over to Kotahira, is heading down south here. It's all just very atypical. And as we continue to scroll through here, you can see we are operating around 7. Only 3 companies have floated. There's totally 3 separate networks here. Absolutely no connections anywhere on the map between any of the companies. This is just really, really weird. And as we continue, we'll just see, it gets even stranger over time. So we don't have to belabor this point, but the end conclusion here is that the end game state just totally misses all this craziness. So we're not going to be able to draw any meaningful strategy points or conclusions based on the final game state. And we'll just click here to, again, illustrate, at the end of the day, this map doesn't end up looking all that crazy, but the way we got here was really a sight to behold. So that was an illustration of the second of 2 flaws. The first one was the tiles and rotations alone aren't adequate. The second is that the final game state is inadequate. And then the final flaw that I would say with the initial approach was that we didn't include any pre-printed track. So if you're trying to analyze the network that players are developing, you really need to include all of the track and all of the tokens that have been placed, because those are going to dictate, the functional network that has been developed. And that's what is going to determine the player's strategy. So recognizing these 3 flaws, I basically went back to the drawing board and totally redid the analysis and the pipeline that will develop the network for clustering. And I'd like to present that for the rest of the video so we can talk about the progress that's been made and any new questions that this type of analysis raises. So this is the old network. And this is a representation of the new type of network analysis. And I know you're looking at this and saying, like, what the hell is all that red? So let me walk you through it. Basically, I have outlined the tiles in this visualization, just as we did in the old visualization. But the tiles that are printed here are kind of irrelevant. What actually matters is the nodes represented by squares, and the red outlines representing the connections both within tiles and between tiles that are contained in the new analysis. So what we've done is basically defined all the edges of the tiles and then all of the internal connections, either in cities or towns or in more complex brown track, as their own edges, and we've created an adjacency matrix that contains all that information. We've also accounted for tokens. You can see that tokens are now represented in the adjacency matrix or in the network visualization. And the reason the tokens matter is because really any given game state has n networks, where n is the number of companies with tokens in the game. So not every company is able to access the track in the same manner, and that changes what the network looks like from the perspective of that company. So we have to include the tokens to capture that dynamic. And then I've also included the pre-printed track and the offboard locations because the network that the players develop runs through those tracks. So you really have to include those to have a complete representation of the game state. And I think that's what we've accomplished. So I think that we now, with this current adjacency matrix, have captured all of the data in the game from a map perspective. This has nothing to do with shares. It has nothing to do with trains. It's just the map information. And I hope that by making a really robust representation of the game state, we're going to be able to get a lot more useful information from this type of analysis. So once we created this new representation with the matrix containing all this information, I basically reran the analysis that I had performed in the past with just the tile and rotation information. And that analysis was underwhelming. And I think that this is where it really drove home to me the importance of looking at the game evolution over time as opposed to the final state. Because as it stands in this image, we're really not looking at the game over time. We're again just looking at the final state, which we've already identified is a problem. So the next level was to basically calculate this type of network or adjacency matrix for every point in time in the game. And let me specify that it's not literally every point in time in the game. I've actually done it in a little more efficient fashion, and we basically just store the adjacency matrix when there's been a meaningful change in the network on the map. So we do a search of the network, and if there's been a new connection that's meaningful, we then store the adjacency matrix at that time. And this ends up with about 50 to 100 matrices for each individual game. And then if you multiply that by, the 1,000 odd or 4,000 odd games, depending on the title, you end up with, 100,000 matrices, and each of these matrices has, 100,000 points. So we're talking about millions of data points. And I think that that's really a much more robust representation of what is going on in 18xx as it's played for each of these titles. And functionally, what that does for us is that in terms of clustering, we now have new dimensions for the clustering algorithm to consider when it's trying to group games. So this is a representation of the metrics being considered for the 1889 clusters. We've done this for 30 and 46 as well. I'm just going to spare you a lot of busy graphs. And you can see that we are looking both at the final game state, the final number of nodes, and this is a representation of basically how many places a train can change directions, I suppose you could say. And we're looking at a number of different metrics for the final game state, but then we're also looking at how many actions occur in a game, the basically metric for the game length, and also how these metrics change over time. So not just the final state, but how they evolve. And by using this, we're able to get a better idea of which strategy may be taking place throughout the game. And you can see that we've got a heat map here. So the clusters just visually kind of look different. This cluster 3 is above the mean for a large number of these metrics, particularly when compared with cluster 2. And you can try and glean some type of strategic insight from that. Now, it's very challenging to do that because, what exactly does the number of total tokens, for instance, tell you about the strategy that a game has taken? But in aggregate, we hope that the clustering algorithms will give us some type of human interpretable information about the strategy that's happening. So that's basically the new approach to this clustering that we've taken. So this is some of the raw data from the clustering for 1830 now. We've moved on from 1889. And you can see that this is kind of an underwhelming result. This is a basically blob, and the clustering algorithm is drawing, what it thinks are different clusters on this blob. But to the human eye, there's really no distinction between the green, cluster and the brown cluster or the light blue cluster. It's all just kind of a blob. So we need to do a little bit of work here to clean this up. And basically what ends up happening is we have so much information, so many different dimensions to this data that it's very hard to visualize and make much meaning from it in terms of its clustering. So we're able to do a couple of different strategies to try and identify the most important dimensions, the principal components, and perform the clustering on those instead. And when we do that, we actually get some more interesting results that may be of use. And this is a visual representation of what that could look like. And you can see we've applied two different clustering algorithms to the dimensionally reduced data. And now we have something that's actually kind of worth talking about and thinking about. And basically, we have this very interesting pattern here where we have maybe a base game state that is dichotomizing, and you have two different kind of pathways where it seems like games can evolve along this principal component in separate directions. So we have, cluster, we'll just call it 2, diverging into cluster 3 and then cluster 4. And then along this axis, the clustering algorithm thinks that there's some type of difference or maybe evolution in game state from cluster 4 to cluster 1 to cluster 0, I guess that is. And just for clarification, the cluster number is totally arbitrary. It's not like they occur in a specific order. It's just for identification purposes. So I thought that this was a very interesting result, but what does this actually mean in terms of strategy or in terms of, human interpretation? I mean, it looks like the data is saying that there's two kind of broad branches of games in the data, but can we actually pick anything out from that data or not? And unfortunately, I haven't really found a way to do this algorithmically. You kind of just have to look at specific games and see, is there a difference between, say, cluster 3 and cluster 4, or do they just look the same? And I specifically wanted to look at cluster 2 because that seems to be the, common denominator, so to speak, between these two branches. So what exactly is going on here? And I think that the results are actually a little bit interesting. So let's look at that in a little more detail. So the first thing I did was I wanted to look at that cluster 2, that kind of nascent or maybe common ancestor for those two dichotomous branches. And I want to just show a couple of those games. So again, these are not anything special about these games necessarily. They're just random games from the cluster. And when I was looking through the games, I picked, 5 representative games, and they didn't really jump out to me at first. I'm kind of embarrassed to say. I was like, all right, they made it to brown. It's reasonably meta track, nothing too incredible going on here. But then as I started going through them, I was said, wait a second, these all have something in common. And what's in common is not actually on the map, but it's instead up here. These are all bankruptcy games. So I thought that was pretty incredible. The fact that we can have a algorithm identify with a very high degree of accuracy that a game ended in bankruptcy just based on the map. There's no financial data included in this analysis whatsoever. We're not including share values. We don't have player net worths. We don't have trains. The algorithm does not know and has no way to know that the game ended in bankruptcy. And yet, just by the features of the map, it is able to identify with a very high degree of certainty that the games in this cluster are bankruptcy games. And I think that's super cool. That is not something that I was really anticipating from this analysis, but it is something that seems to be holding true. And it kind of makes sense, right? If we go back to the picture here, if these are bankruptcy games, they're kind of a less developed game state because the game ended earlier than you would otherwise expect. It kind of makes sense that you would have games kind of extending along this axis from this. And this may be that these games are lasting a little bit longer and the map is a little bit more developed. So the next obvious thing is to look at, the other clusters similar to what we just did and see if there's any defining characteristics that we can pick out with our human eyes that have strategic implications. So again, cluster 2 here seems to be bankruptcy games. What about the rest of these clusters? What do they contain? So we just worked along that axis, and now this is a cluster 4 game, and I wasn't all that impressed. Cluster 4 ended up being another bankruptcy cluster. Almost all the games ended in bankruptcy. But really, it doesn't look like the game state is all that much more advanced. This is this is a cluster 4 game. Compare this with one of the cluster 0 games, and I wouldn't say that the map looks all that different. But really, maybe that's consistent with the idea of this existing along a spectrum. So if I think I said cluster 0, but I meant cluster 2. Cluster 2 and cluster 4 are adjacent to one another. So maybe if these are both bankruptcy games, the map on the cluster 4 is not really all that much developed than cluster 2. And that, of course, just leads us down the line. What about cluster 1? And cluster 1 kind of conforms to our expectations. This is an example of a cluster 1 game. You can see it didn't end in bankruptcy, and the map is a lot more developed. So as we're progressing along this axis, the games seem to be a slightly more developed game state or later game state. So then if we continue one more time, and from cluster 1 we head over here to cluster 0, which is furthest along this axis, cluster 0 starts to look even a little more advanced or developed. So this is the end of the axis, the kind of most advanced game state. And as we cycle back through them, you can see that the map will become a little bit more primitive. So this is the end axis, the most developed game state. This is slightly less developed. We don't see quite as much development over here. And then we go back to the earlier axis, and then we're ending in bankruptcy with a very kind of immature game state. So I think that if we look at this axis as a proxy for game development, it actually seems to hold water. I think that actually is what we're seeing in this. But the big question here is what is going on with cluster 3? What distinguishes cluster 3 from the rest of these clusters in this development axis that we've identified? And that is a very hard question to answer, actually. Cluster 3 doesn't visually look all that different from the games in this axis here. It doesn't appear to be a bankruptcy cluster. But the big distinction between cluster 3 and these other games appears to be that cluster 3 is just earlier in the website's history. So temporally, just earlier in time. So these are games from 2020 and 2021, whereas the lower axis here seems to be games from 2023, 2024, etc. So I think what this is telling us is that cluster 3 represents a change in the API or a change in the implementation of the game, rather than a true difference in strategy. And that is a huge problem for this type of analysis, because if the data set is not consistent over time, we're going to start having a lot of confounding effects, a lot of non-strategic impact on our results. The other problem here is that it's just very hard to work with this data. A lot of these games are archived, so I don't have an easy way to visualize these games as I've been doing throughout this video of just plugging them into the website. I have to create my own kind of homebrewed way of visualizing these games. So it's just very challenging to tell what exactly is going on in cluster 3, other than the fact that these game IDs are typically much lower than the other game IDs. So most of cluster 3 is like game ID 30,000, as opposed to cluster 4, cluster 1, etc., where the game IDs go up to 200,000. So while I think that there is a signal here, I think the signal is probably not strategic. In fact, it's more artifact from a fact that the website changed in some way that I'm not entirely sure yet. So I think it's super interesting that we were able to identify bankruptcy games, and I think it's true that we've identified some kind of evolution in the game state with this analysis. There's still pretty clearly a big flaw with this data, and I'm not entirely sure how we're going to overcome this. So I want to switch gears here and change from 1830 to 1846. The analysis for 1846 was performed exactly the same, but the input data, of course, is different. And I think that we can have a little bit of an interesting discussion about the strategic implement, implications of the 1846 data. So I want to switch gears there and show you that. So we'll begin that by looking at the analogous plot for 1846 that we were just looking at for 1830. And I think it's pretty clear that the shape of the data, or the way the clustering is looking at this data, is very different for 46 than it is for 30. We don't have a clear evolution along a specific axis necessarily. Instead, we really have dichotomous outcomes where we have a blob of games, on the left of the first principal component, and then a blob of games on the right. And the clustering algorithm is calling different clusters within these blobs, which aren't visually apparent to my eye as a human. But again, this is dimensionally reduced data. So maybe if we were to plot these along slightly different axes, we would see that these light blue clusters are actually distinct, or these green and brown clusters are distinct. It's hard to tell based on this picture, but I think that we still have some interesting data to talk about. So along that line, I will show you a slightly different graph of the same data, just plotted differently. And that is here. So this is a slightly different dimensional reduction technique, and you can see the data looks very different, but I don't want to get into that too much. The important part is that it shows us the clusters in a slightly more human readable format. And you can see the two clustering algorithms, the k-means and the HDB scan, perform very differently. So we're going to focus on the k-means because I think it's unlikely that in reality 1846 can be dichotomized into just two clusters. I think the idea of having 5 clusters is slightly more realistic. So we're going to put aside the data on the right hand side of the screen and just focus on the left hand side. And we can see that the algorithm has identified reasonable clusters. So as a human, I think it's reasonable to say this light blue cluster, is distinct and separate from the brown cluster, from the gray cluster. Clearly, there's still some questionable calls here, like, are these 2 brown clusters really the same type of game, or should we perhaps introduce a 6th cluster for this little island here? How real is this cluster distinction between the blue and the green? So there's still maybe room for improvement, but I think that this is just a more useful, division of the games than the information on the right. So similar to 1830, I wanted to go in and just look at the data from the games of these individual clusters and see, what kind of information I could draw from this. Is there, a clear difference between these games? And unlike 1830, there was actually a very important distinction that immediately became apparent. And basically, the distinction is that clusters 0, 2, and 3, so 0 being the dark blue, 2 being the brown, and then 3 being the gray, were very different in terms of time than clusters 1 and 4, cluster 1 being the green and cluster 4 being the teal. So the games are distinct based on the time they occurred, which is something that we saw in 1830. But in 1846, I was actually able to pinpoint the exact difference that occurred, and it actually seems to be strategically relevant rather than just a change in the way the data is reported by the API. So the interesting thing that I discovered is that the change in these clusters occurred on a very specific date, and that date is basically May 25th of 2021. So I looked at, I thought to myself, well, what changed on that date? And I got lucky, and I was able to find on BoardGameGeek a post from that date explaining exactly what changed. So I'm going to just pull that up. So here's the post, and this is from one of the devs of 18xx.games on Board Game Geek, and I'll draw your attention to the date. And what he's talking about here is the introduction of the second edition private companies into 1846 on the website. So this was totally unexpected for me. I did not go into Board Game Geek and look for dates and then go back into the data. Instead, I looked at the data and I found the exact date where the change occurred. And then I went to Board Game Geek and found this post. So this is something that the data discovered, not I discovered and then read into the data. And I think that's super powerful. And just what I mean by that, because it may not be entirely clear, is that I have a clustering, raw data here. And you can see that there's a jump in the numbers because there's a discontinuity in my data set because of the archiving and just my lack of diligence in collecting the data. So we have a set of data that extends up to almost 40,000, 39,000. And almost all of the games in this earlier set of data are zeros and twos, clusters, zeros and two. You can see that there's an occasional three, or there's some threes, but there's basically no ones or fours in this set of games in terms of clustering. And then we get into the new data and we see that they're almost exclusively ones and fours. So what I did was I looked at this specific game here on the website and I said, well, when did this switch occur temporally? And when we look at that, we see that this game ended on May 25th of 2021, the exact same date that this post occurred. So it seems to me that there is a very strong temporal delineation between these two clusters that we've been, or sets of clusters that we've been looking at. And they seem to correspond to the introduction of the second edition privates. So what exactly do the second edition privates do? And is it reasonable to conclude that they may have changed the strategy or the map development in 1846? Let's talk about that. And I think that that really lends credence to this argument and this thought that the clustering is truly picking up a signal here as opposed to just a coincidence or just noise. Because when you look at the second edition privates, you can see that they both affect Cincinnati, which is a very specific area of the 1846 map. And you can imagine that if you introduce new privates into the game that overwhelmingly impact this small section of the map here, that is going to, potentially really change the way the map develops. So I did go through the clusters and just look how many of them included Boomtown and Little Miami, the second edition privates, in each of these clusters to determine if there was a correlation, I guess, between the presence of these privates and the cluster that these games appear in. And when I did that, I did find that, in fact, clusters 0, 2, and 3, which are the, I guess, introduction of second edition private clusters, seem to be less likely to include specifically Boomtown than their fellow games in clusters 1 and 4. So even games in clusters 0, 2, and 3 that have occurred after the introduction of the second edition privates, these games tend to not include those privates in the random selection of privates. So it does seem like the game or the clustering analysis is picking up that there is a different focus in the game, perhaps a little more emphasis on the Cincinnati region in certain clusters. So I would be very curious to hear from Tom Lehman, did he introduce these privates with the intention of kind of bolstering map development in this region? I have to imagine he did. And whether or not he has noticed a change in players' behavior after the introduction of these privates, and if the map starts to look different after the introduction, because I have to imagine that it has had a change that is detectable, and I think that's what we're seeing here. So I'm very pleased by the cluster analysis being able to pick up something like the introduction of new privates and the impact on the game, and for 1830, for instance, the existence of bankruptcy games. I think that this is almost like an emergent, behavior for this analysis, one that I did not explicitly code into it, but one that is highlighting the fact that there is a true signal in this data, and it's not just all noise. Um, we have data for 1889, but it's just not really as interesting as the 1830 and 1846 data. So I'm going to basically spare you that analysis for the purpose of this video. Um, so, I'm going to wrap things up here. I think that we've covered some important things. I think that there's a lot of potential for this type of analysis, but I think there's also very clearly a lot of work that remains to be done. I think that we're picking up very kind of big signals, or big signals are standing above the noise in this type of analysis. Things like bankruptcy, things like new rules in the game. But I wouldn't say that I'm impressed by the resolution of this analysis, in the sense that we still have not reached the point where I'm able to say, this type of game, the IC, developed along the West and raced to Chicago, versus in another game, the IC maybe headed over into the Big Four and then headed east. That type of level of analysis is still very much not possible with the approach I've taken. And I'm not really sure how to bridge that gap. I'm not sure how to progress from where we're at. So I think there's going to be a lot of thought on my end, and hopefully thought on your end, and comments from you on ideas of how to take this to the next level. Because while we've made progress, it's really not the amount of progress that I was hoping for. And I don't think we have the deep insights or, really granular, strategic analysis that I was hoping to achieve with this, if I say so myself, rather robust, representation of the game state and game data. So I'd love to hear your thoughts about where to go from this, and I will continue to think about it as well. I do think that we will have future videos on this, but I think the progress is probably going to slow down a little bit. I imagine that we are going to hit a little bit of a time period where I just have to think about things and determine where to go next, rather than just beat my head against the wall and struggle with this data. So I appreciate you taking the time to listen to this video. Hopefully it's been interesting, and Track Talk will be back in the future.